Hi everyone, welcome to our video on simplifying rational expressions. There's two kinds of rational expressions that we will deal with simplifying. We've got our first two, these are kind of connected. Multiplying and division are very similar, and then adding and subtracting are very similar, and we take two different approaches to them. Okay, so with multiplying or dividing, we want to use our kind of general rule where if you have a common factor divided by a common factor, it is equal to 1. So for instance, like x plus 3 divided by x plus 3 is 1, because it's the same thing divided by itself. Or 2x squared over 2x squared is 1, because again, it's the same thing divided by itself. Be careful though if the sign is different, so if you had x plus 3 over x minus 3, then this does not simplify. So that is simplified all the way. Okay, so be careful of those signs, but we'll take this into advantage into these problems. Okay, so to multiply, really all these, when you have multiplication or division, it really is just factor everything. So simplify, our first step really is factor all numerators and all denominators. All numerators and denominators. Denominators. Okay, so there we go. Okay, so factor every one of them, and there's these. I say they're implied parentheses. They never really show them, but they are there. Okay, so when we simplify this, so this 5x plus 20. So let's go ahead and just get our fraction bar set up, and then there's the times. Okay, so 5x plus 20. Well, 5 is common in both of those, and we could take that out. And we're left with x plus 4. And then I like to put the parentheses around the factor that got taken out, just like that. So 5 times x plus 4. And again, always check with multiply as you go. So this does match that one. 10 is 10. Again, we could just leave it as 10. Up above, x squared minus 2x minus 8. So this is one of the ones that we need to, this is a trinomial that needs to factor. Okay, so, and I'm going to do kind of the scratch work way over here. So 1 times negative 8, and I might erase it afterwards in case we need to save room. Okay, but we have 1 times negative 8 is 8, and then the factors of 8 are 1 and 8, and 2 and 4. And I need a negative 2, so I think I need a positive 2 and a negative 4. Okay, and then because the coefficient is 1, we could use our shortcut and say that this factors into x plus 2, x minus 4. And then quickly check, multiply, it does match what's above, so that means we factored it correctly. Our bottom one here, x squared minus 16, that's our difference of squares. That means we just think, all right, well, what times itself is x squared? Well, x is. And then we always do minus and plus, or plus and then minus. Either way, it alternates. And then 16, well, what times itself is 16? Well, 4 is. 4 times 4 is 16. And there we go. Okay, and so from this point, so this multiplication, when you do multiply, everything through the numerator multiplies, everything through the denominator multiplies. So it really, let's write it like this. So I'm going to write it just like this. So here's everything in the numerator, all divided by everything in the denominator. And then that way I've got all my factors ready. Okay, and then now I'm just looking to see what are in common that I can divide out. So they don't have to be right on top of each other. It's just anything in the numerator divided by anything in the denominator that's the same cancels. Okay, so x plus 4 and x plus 4 divide and make 1. So that means we don't need to write them anymore. And then the x minus 4 divided by x minus 4 also makes 1. Okay, so then one last thing that we do have, when looking at the numbers, so 5 divided by 10, well, these are just regular old fractions. And just to show a little bit of scratch work, 5 divided by 10, well, we know that that is 1 over 2. Okay, so those simplify just like regular old numbers. Okay, so any variable expression, we're looking for exact matches to cancel. Okay, so we've got this now becoming, so the 5 divided by 10, let's go ahead and put a fraction bar. 5 over 10 became 1 over 2. the x plus 4 and the x plus 4, I mean, we could write it. We could say that those do divide and make 1, but typically we don't really need to show 1. Okay, so let's just move on then. And then really the only thing that's left is the x plus 2 in the numerator, just like that. Okay, and then now we have our final answer. We just have to simplify it one last time. Let me kind of block that off and put it... That doesn't look great. Let me erase that. There we go. Okay, so I'm going to squeeze it in right here. Well, 1 times x plus 2 is just x plus 2. And then 2 down below is just 2. There we go. And that's it. Okay, and notice this 2 and that 2 will not divide. When you do division, they have to have the same number of terms. So for something in the numerator to simplify with something in the denominator, it has to have the same number of terms. So because this has 2 terms in it up top, x plus 2 is 2 terms, it does not divide with a single term, the 2 there. Okay, so that does not match. And you could always, if you're ever confused with numbers or with these division rules, like say for instance you had 4 plus 8 divided by 4. Well, the 4 plus 8, so this is just regular numbers, 4 plus 8 should be 12, and then divide by 4 should be 3. If you were to break the rules of math and say, hey, 4 divided by 4 gives us 1, and then 1 plus 8 is 9, well, then I get different answers. Okay, so this was the wrong way. Up top was the correct way. But with variables, we can't really do it because variables don't combine well with constants. But we still have to recognize, hey, that rule there would have applied, and I can't take this 2 and divide by 2. It's breaking the order of operations. Remember parentheses, just to put that in. I'm going to just write that in right here. Please excuse my dear Aunt Sally's loud radio. Parentheses would be before multiplication or division. So it wants to do this addition, and then later it would want to divide. But because the variable, it cannot do the addition. It just has to stay as is. Okay, so be careful of that. So only the same number of terms divide with each other. All right, anyway, so let's take a look at this one here. So this division problem. Let me go ahead and erase that scratch work so I can make sure everything's going to fit okay. All right, so I'm going to put this one kind of horizontal, and then we'll go down left to right. All right, either way, I want to do all of the factoring right here. And it's up to us when we want to apply the rule. Let's go ahead and apply it right now, actually. So when we divide two rational expressions, so this is true for any fractions that are getting divided, we want to keep the first fraction as is, change the division into multiplication, and then flip the second fraction. So I say keep, change, flip. So we've got x squared plus 8x plus 15 over 8x squared plus 24x divided by changes into multiplication, and then flip these two around. So 2x squared minus 18 is now up top, and then x squared minus 4x plus 3 is down below. Okay, so now it is just like multiplication. So division is really multiplication. It just takes one step to change it into multiplication. Okay, and then now let's factor everything like we did the last problem. Okay, so let's go ahead and set up our parentheses or our fractions. All right, so this top left one, x squared plus 8x plus 15. Again, we could do our scratch work to figure it out. 1 times 15. So I'm going to erase these as we go since I'm going to run out of room. Is 15. And then 1 and 15 are the factors, and 3 and 5 are the factors. Well, it looks like it's 3 and 5 that need to be done. Positive 3, positive 5, to make this simplify into its factored form. Okay, and it is a coefficient of 1, so we could use our shortcut, x plus 3 times x plus 5. Okay, very nice. Okay, and then the bottom left, it looks like it's just a greatest common factor scenario where 8x is in common. So I'm going to take the 8x out, and then we're left with x plus 3. Okay, 8x squared and 24x. Yep, that matches. Okay, so that one was nicer. And then up top here, it looks like I can take a 2 out. So the greatest common factor is 2. And then I'm left with x squared minus 9. Okay, and then the bottom right, x squared minus 4x plus 3. Well, again, I need some scratch work, or if you know it without scratch work, then that's fantastic. Just move on and write it. If you need it, though, let me go ahead and do it here. So I have 1 times positive 3 is 3. There's only one option. The factors of 3 are 1 and 3, and it looks like I need them both to be negative to match the negative 4. Because the coefficient is 1, I could do my shortcut, x minus 1 times x minus 3. Okay, so there's that. So I did the scratch work. Let me just erase it to clean it up. Okay, anyway, so everything looks so good so far. Now, the x squared, that's an issue still. This one right here. If you have any power greater than 1, so if the power is 2 or larger, look to continue factoring. Okay, so power of 2 or larger, still look to factor. Okay, so this in the blue, I can still factor. That's the difference of squares. Okay, so let's go ahead and rewrite it. Okay, so this becomes, now I've got, this is still the same in the top left, so x plus 3, x plus 5. Now the way I'm going to write this bottom one, I have 8x attached to it because that's how I did the greatest common factor, but I'm going to write it as 8 and then just x in parentheses, so I can see just the numerical portion first. So 8 and then x plus 3 times 2 in the top. And we said this is the difference of squares. Well, x times x is x squared. So here's my setup. And then I see 9 there, so I know 3 and 3 make 9. And so that's now completely factored. And then down below, I still have x minus 1 and x minus 3. Okay, so I didn't give myself the best room, but in this step, let's go ahead now and see what's in common with our numerator and our denominator. All right, so I'm going to highlight, so x plus 3 and x plus 3 are common, so they cancel each other out. And then what else? We've got, I'm going to just keep it in yellow, x minus 3 and x minus 3 cancel each other out as well. And then now looking at what I have left, x plus 5, I don't see that down there, so that stays as is. X plus 3, I don't see it. I've already canceled it, so I can't use it again. So that looks like it's it. Except for the number part. So the regular old 2 divided by the regular old 8, that would be 1/4 or 1/4. Okay, so I'm going to do this one. I'm going to do a cross. So that would be 4 and that would be 1. Okay, and again, everything that's highlighted in yellow is gone. So our final answer, I'm going to squeeze it into this spot. Sorry about the room. Our final answer is, well, the 1 I don't really need to write. Let's just write the x plus 5 and the x plus 3. Like that. And then down below, well, the 4 I do need to write. 4. And then x. And then x minus 1. And there we go. Okay, so that's how those work. So it's really just a lot of factoring. It's really just a bunch of factoring problems in one with a little bit of extra after. Okay, so adding or subtracting rational expressions follows a different rule where we need a common denominator. So we must get a common denominator. So just like with regular old numbers. Okay, so, and it works in a similar way where first, if we can, we want to factor. And then afterwards, if we cannot, well, then we'll start to get our common denominator. Okay, so like in this first one, if I want to add these two rational expressions together, I must get a common denominator. And so our denominators are x and x squared. Well, if it helps, let's go ahead and write this like this. I'm going to write it as 5 over x plus 3 minus x over x squared is x times x. Okay, so I just want to show this in a slight different way, and you could always put the parentheses 2 if needed on all these. So x times x. Well, this shows me I have x already on this left one. I'm missing one of these other x's. So that's all I need to include. So I need another x with this one. Then I would have a common denominator. And whatever you do to the bottom of a fraction, make sure you do to the top. And so now we've got 5x plus 3 minus x over x times x. Let's go ahead and just say that that's now x squared. So now I can just combine it into a single denominator. Okay, and then now it's just going to simplify. So the positive, it is a positive 1 in front. That would distribute. So we'd have 5x. Positive 1 times 3 is 3. Positive 1 times negative x is negative x over x squared. And then one last thing, it looks like I have some like terms. 5x minus x would be 4x plus 3 over x squared. There we go. And then that's it. And remember that, like, even at the beginning, this x squared does not cancel with that x because they do not have the same number of terms. This has 2 terms in the parentheses. This only has 1. Okay, so that means it doesn't cancel. And remember multiplication, so this, you might say, hey, now isn't it 2 terms, x times x? No, multiplication does not count as separating of terms, only addition and subtraction does. So x times x, that's still a single term, so that means do not cancel with anything up top like that. Okay, anyway, so that's that. Now, with this problem, note whenever you have a trinomial, so like this, or even a binomial, you usually want to think, hey, does it factor? Often we factor. We factor a lot in this class, so look to factor on these problems before anything else. So let's factor what we can. So 4x minus 1 is fine. Down here, and let's go ahead and put our implied parentheses too, actually. Okay, so I'm just going to set it up slightly. So 4x minus 1 in parentheses up top. This does factor, all right, x squared plus 5x plus 6. I have a 1 in front, so it's 1 times 6 is 6. The factors of 6 are 1 and 6 and 2 and 3. I need them to add up to 5, and so it looks like I should do plus 2 and plus 3. Notice those do multiply to give us 6. Because it's coefficient of 1, I can shortcut method it, x plus 2 and x plus 3. Okay, and then minus. Okay, so let me go ahead and erase that scratch work. Again, if you're feeling good about factoring, I mean, that's fantastic. I hope you get to the point where you could just jump to it. Okay, but minus the x minus 3 in the numerator there. And then 2x plus 6, it looks like 2 is in common. I can factor that from those 2 terms. So 2x plus 6, 2 got taken out. I'm left with x plus 3. Okay, so now it's similar to what we did on that last one. All I want to do is just look at what I have in my denominators. Notice I already have x plus 3 in common. So I don't need that again. However, I have a 2 in this right parenthesis, or in this right denominator, and I don't have just a 2 hanging out here. So that means I need this 2 to get put in. And then now I've got a match. Now I have 2 and 2 matching on my denominator. But then I see, oh, x plus 2 is not in common with both, so I need to put an x plus 2 here. And the order doesn't matter because it's multiplication. Okay, so it doesn't have to match exactly the same. That you could always rearrange with multiplication. So I'm just putting it at the end. And then, well, again, whatever I do to the bottom, I got to do to the top. X plus 2 like that. And then now I have a match of everything. So I'm just underlining to show all of my terms in the denominator, or all of my factors, I mean, in the denominator are there in each fraction. Which means now I can rewrite this as a single fraction. So let's go ahead and just write it as 2, x plus 2, x plus 3. So there's all 3 factors just put into a single fraction, or in single denominator like that, and a single fraction. Okay, and then in my numerator, let's go ahead. I'm going to take this time to write this step. We're going to do it in a couple maybe extra steps, but let's write it as in all these parentheses, so 2 times 4x minus 1 minus x minus 3x plus 2. Now this minus here, be careful with, this is going, it will want to distribute through everything. So this whole numerator is in implied parentheses. So that means this minus will want to minus everything once it's simplified. Okay, so now all we want to do here is FOIL this out. So let's go ahead and get our big fraction bar. And just set up your denominator. That's what's good about it. Once you have it, is just rewrite it. Now, in my numerator, I do want to distribute. So the 2 distributes through. So in this, I'm just going to show it in green. The 2 distributes. So I'd have 2 times 4 is 8. Attach the x. And then negative 2, so 8x minus 2. And then I have this minus, but let's get the blue parentheses still there. And what I need to do here with this portion is FOIL. So I'm foiling this out. So x times x is x squared. X times positive 2 is 2x. Negative 3 times x is negative 3x. Negative 3 times positive 2 is minus 6. Okay, and so we're getting there. Now, I want to, let me go ahead and simplify one more time inside this parentheses. Notice 2x minus 3x is in common. Okay, so just to write the denominator again. I'm running close on it. I'm running out of room. Actually, let's do it like this. So I'm going to go ahead and just distribute the negative now. So through those 4 terms, and then afterwards, let's simplify everything. So I have 8x minus 2 minus x squared minus 2x plus 3x plus 6. Okay, so the negative is just changing all the signs. But now I can go through it and finish this problem off. Okay, so let's just get our denominator. There it is. And then in our numerator, it looks like I just want to collect like terms. I'm going to go ahead and put it in descending order too as we go. So the negative x squared, let's go ahead and cloud it. The negative x squared, I'm going to put first. And notice the negative is above the fraction, so don't put it too far out. Don't put it like over here. Then that would be something different, so be careful with it. So make that big old fraction bar. Okay, and then we see, to continue putting it in descending order, I have my x terms. So 8x minus 2x plus 3x. Okay, so 8x minus 2x is 6x, plus 3x would be 9x. So plus 9x. And then our last one we have is minus 2 plus 6. So those are just regular old numbers. That would be positive 4. Okay, and I kind of wrote my fraction a little weird. It's a little big, but after that, it's all done. Okay, so there's our 2 methods. So only a couple problems. So if you need more practice, well, there's other videos as well that you could check out that are not done by me. But you could also do the problems that are in the study plan, that are in my math lab, and so forth. Okay, so if you do need help, if you need to ask me questions, don't hesitate. Please let me know. Otherwise, thank you for watching, and I will see you again next time.